Hello and good day to my EEGU lecturer, Dr. Hafisoh, and to the listeners. I am Sarrvish Subramaniam from Taylor's University, and I am here to talk about ultrasonic welding. Okay. So let's dive straight into the ultrasonic welding applications in daily life, which is currently happening. So the main application of ultrasonic welding is the welding of thin metals and plastics. So this welding technique can mainly weld thin metals such as aluminum, copper, nickel, and plastics such as thermoplastics. So they are mainly used in the automotive industry, which is welding cars, their doors, their bonnets, and also the electronic industry, welding microchips, etc. And also many other industries such as the toy industry, plastic industry. So yeah, ultrasonic welding is present in those small industries as well. Now we dive straight into the diagram of the ultrasonic welding. So here I will explain to you about how this process works. Okay. So we have the few main components over here. So we have this ultrasonic generator and this pneumatic press. We have the transducer here, the booster, the horn or sonothrope, and we have the fixture or nest or anvil. This is where the placement of these materials will be, and we have this yellow is the plastic material over here. So this ultrasonic generator, it will receive electrical current from the main power supply, and it will convert the electrical it will send to the pneumatic press, and the pneumatic press it will send these electrical signals to the transducer. This transducer, once it receives the electrical signals, it will convert the electrical signals into mechanical vibrations. So once the transducers are done its work, it will move over to the booster, which amplifies this vibration even more, make it higher in terms of frequency. So this horn and sonotrode, it will uh, divert all the mechanical vibration it receives from the booster into the place where you would like to weld. So this material, it can be plastic or metal. It's up to the owner or the handler. So yes, that is how this ultrasonic welding works. Okay, next. Next, why do people choose this technique over the other welding competitors? So first of all, the main point we have to note is it is an automated welding technique. There is no need for the presence of a welder in this. All you need is an operator or a handler. That is all. So it is fully machine based. So therefore, there is no need for hiring or a professional welder to take uh, to do this process. So it is 100% handled fully by the machine, and yes, the operator must input before the start of the welding, must input the frequency and what type of material we're using onto the control system before the start. So it is also a fast process compared to its competitors. So it can produce a high number of welds during the working hours compared to the other techniques. So it is a fast process. The only time where it might take we only process where it might take some time is the cooling period, where it might take around 1 to 2 hours for the well to cool. So once the weld is cool, it's basically done. So that is where it might take some time, sorry. So it is also capable of welding thin metals and plastics, as I said before. So the advantages of welding, it is a fast welding process. Yes, it takes a short time for the vibration to cause the metal or plastic below to melt and combine, and then obviously the cooling period takes it's a few hours to cool, and then the well will be complete. Also a very environmental friendly method, as it is fully machine operated. There is no unnecessary waste or unnecessary pollutions produced during this while using this method. Also, it's a fully automated process, so this is definitely the main advantage. Because as the other competitors, we can see it's all requires a welder, so there might be human error and whatnot inside there. So this is 100% automated. So next is yes, as I said before, it can produce more wells in a day compared to its competitors. So it's a machine, so you put in how many wells you need in a day and it can produce up to that. And lastly, it produces a clean and neat well finish, so there is no need for unnecessary touch-ups to the well, and overall it produces a neat finish. Okay, next. Well, when there are then there is some good thing, there is also some bad thing. So these these welding techniques, there are some limitations, which is the size limitation, which means this machine can only accept a certain size of material. So let's say if it is too thick, then it cannot weld, because the vibration, it's harder to vibrate the materials to make them heat up if it is too thick. There is some material limitation, which means some thick metals or some thick plastic cannot be welded using this process. And also it is since it's automated machine, it is a costly initial buy lah for any companies who like to purchase. And also the maintenance cost is also high, as you need to service regularly, because if it is faulty inside, then it might not produce a proper neat finish. So that is when, if there is some wells which is having some error, that means that is when it's time for a service. So that service might cost uh, quite high, and also the replacement parts will also cost quite high. And also there are some chances of noise pollution to occur inside within the area of the welding, because obviously the vibration towards the metal or plastic, it will keep on hitting on the material. So therefore there might be chances of some noise pollution, especially if there is some faulty parts inside. So then it might have a louder sound lah. And lastly, the room for improvement. Well, since it's an automated process, there is currently not much improvement that can be done in its how to say, the machine. So it's already automated, so that's the best it can be done lah. So maybe we can make it more affordable by using cheaper parts to build this machine, so that a normal company can use it, can purchase it. And the other room is to try to reduce this noise pollution lah. So service regularly, maintain it, handle with care, so etc. lah. So that is all from me. Thank you for listening. Bye bye.